So today we're going to be looking at comparing functions. And the essential question we're looking at is how can you use tables, graphs, and equations to compare functions? So we've done a lot of work on determining whether your function is linear or proportional or non-proportional. So now we're really kind of taking all of that and comparing the functions and see what the implications of them are in a real world context. So let's jump into an example. In this first example, Josh and Maggie are buying MP3 files, which are like after CDs, but before Spotify. So from different music services. And the monthly cost Y dollars for X songs is linear. The cost of Josh's service is Y equals 0.50X plus 10. And the cost of Maggie's service is shown in the table. So Josh's service is in an equation, which is really easy to understand because remember, since it's in that Y equals MX plus B form, the 0.50 represents the slope or the rate of change. So in this case, it's 50 cents per song with a starting fee of $10. That's literally what the y-intercept represents in this equation. So I have an idea of what Josh is paying, but Maggie's is given into a table, which gives me an idea for, it looks like every 5 songs, but not necessarily enough information to compare it to Josh's explicitly. So what we're going to do is we're going to write an equation for Maggie's so then we can compare it to Josh's. So how I'm going to write an equation for Maggie's is that first I got to find the slope, because no matter what, if I'm going to write it in y equals mx plus b, I need to have my slope. So remember, to find the slope, we're going to use the slope formula. So m equals y2 minus y1. In this case, y2 is 990. Just going to make a fraction. 990 minus y1 is 495. And again, that's just the second number minus the first number over x2 minus x1, which is 10 minus 5. 990 minus 495 is 495. And then 10 minus 5 is 5. So I have 495 over 5. And then if I just divide 495 by 5, I'm going to get 0.99. So this tells me that Maggie's are costing 99 cents per song, because that's the slope. So then what I need to do now is make an equation. So I can either find the y-intercept, but I'm actually going to put it into point slope form. And the reason why I'm putting it in a point slope form is because remember, I just need 1 point. Well, and in the table, I'm given 1, 2, 3, 4, 5 points. So this is really easy to work with. So I'm just going to choose the first point, that 5 and 495, and go ahead and put it into point slope form. So remember, that's y minus the y1's 495 equals m, which we said was 0.99, parentheses, and then x minus 5. That's the first x value. Now I have it in point slope form. I can go ahead and evaluate by doing my math rainbows. So multiply the 0.99 to x, 0.99 to 5. When I do that, and we'll try to see if we do it okay. We get y minus 4.95 equals 0.99x, because remember, when I multiply the 0.99 to x, it just kind of slaps it together. And then 0.99 times 5 is going to be minus 4.95. Okay, so now I'm in my last step. I just need to add that 4.95 over so I can have y by itself. So plus 4.95. 4.95. What's really neat is when I do this, you'll see that my 4.95s are going to cancel because they're opposites on both sides. So it cancels here, it cancels here. So I'm left with a proportional relationship where y is just equal to 0.99x, because again, my 4.95 is canceled. So Maggie's equation is just 99 cents, which means Maggie's service doesn't have a starting fee, but it does cost more per song. So one way we can kind of check and compare, so like just by looking at the slopes, I know that Maggie's service is going to cost more per song because it's 99 cents per song, whereas Josh's is only 50 cents per song. And then, but Josh has to pay more up front because Josh immediately has to pay $10, and then it's 50 cents per month. So we are going to try to determine which one is going to be cheaper when 30 songs are downloaded. So how I do that is I'm just going to plug in 30 for X, because remember, it's 99 cents per song, where X is the per song. So just to figure out how much the cost is for 30 songs, I just plug in 30 for X. So I'm going to do it first I'm going to do it over here. So remember, Y equals 0.50 times 30 plus 10. And then I'm going to set it up over here because I need to do it for Maggie's equation, which is 0.99x. And then Maggie's equation, we'll do it in a different color. So Y equals 0.99 times 30. So then if I do the math, I got to figure out what 0.50 times 30 is. Well, 0.50 times 30 is 15. So Y equals 15 plus 10. So Y equals 25. So this tells me that for 30 songs, it's going to cost Josh $25. So now I need to figure out how much it's going to cost Maggie. So Maggie, I just got to do 0.99 times 30. Which is $29.70. Even though Maggie's is less upfront, over time, Maggie's service is going to cost more. So then I need to just write a sentence that kind of establishes that. Remember, the blue equation is Josh's service, and the pink equation is Maggie's. So as time goes on, or the more songs you buy, the cheaper Josh's service will be. Time goes on, Josh got cheaper, but Maggie's definitely is getting more expensive. All right, so that's just kind of one way we compare. So now we're going to look at comparing a table and a graph. So the table and graph show how many words Morgan and Brian typed correctly on a typing test. For both students, the relationship between words typed correctly and time is linear. So we got to find Morgan's unit rate and we got to find Brian's unit rate. And the way we do those are different because with Morgan, I'm going to use just the table, do the slope formula. But with Brian, I can use rise over run, which is kind of cool. So let's go ahead and find Morgan's first. So finding Morgan's, I'm going to use that slope formula again. So M equals, and then I'm going to do 60 minus 30, y2 minus y1 over x2 minus x1, which is 4 minus 2. 60 minus 30 is 30. 4 minus 2 is pretty easy, that's 2. And then 30 divided by 2 is 15, which means that Morgan types 15 words per minute, or 15 words per minute. It's not very fast. Let's figure out Brian's. So then Brian's unit rate we're going to use, I'm going to kind of zoom in a little bit so we can see it a little bit better. Look at how much that's zoomed in. All right, there we go. So then for Brian's, I'm going to use rise over run. So remember, starting at the origin, which is 0, it looks like it's going up 1 over 1. But notice that this is not counting by 60, by 1. So this is counting by, looks like it's counting by 20s, 20, 40, 60. So which means I'm going up 20 over 1. So 20 over 1. And remember, since slope is rise over run, I'm going to write M equals, oops, that's not what I want to do. We'll do it in blue so it matches what we just did. So M equals, and then I'm going to type the word rise over run because we're using a different method. We're still finding the slope. We're just finding it from the graph instead. And since my rise is 20, that means it's 20 over 1, which is 20. I'm going to zoom out now so I can see the rest of it. All right, so since, oh my goodness, I put this in the wrong area. Put that back up there. So as you can tell, Morgan's unit rate is 15 and Brian's unit rate is 20. So because Brian has the higher unit rate, that means Brian's going to type more words, right? Because 20 is bigger than 15. So again, this means that Brian types 20 words per minute and Morgan only types 15. So which student types more? Well, Morgan, because Morgan has the higher unit rate. Or sorry, Brian, my goodness. Brian types more words per minute as he types 20 words per minute. and Morgan only types 15. Both of them are pretty slow, but that's why they got their typing class. Alrighty, so hopefully now you have an idea of how to compare linear equations in their different forms, and really the key is looking at the slope. If the slope is bigger, it's going to be more expensive over time. It's all in the slope.